Okay, regarding the dropout, we have done a special training of Learned using dropout. Um, so the first thing is to open the script. Okay. And the only changes with respect to the previous training code is that after the second pooling layer, we have set a dropout layer, and another one after the ReLU 3. So I have set the dropout with a drop rate of 70%. It's quite high. Usually people use 50%, but I wanted to show you like how to really force how to force the avoidance of overfitting in a drastic way. But usually you need to play a little bit with these factors, so, and also where to place the dropout. I have done several experiments until I found where to place them, but usually it requires like some experience to really learn where to put them and how many of them to set. This idea of dropout was introduced by Benjio, and I would recommend you to read the paper that you can find in the references. In any case, let's gonna run this training. Let's keep using Hessing's. You see that now things are not behaving really so on. So this is one of the effects of dropout, since like we are randomly destroying parts of the connections. So with the objective loss and the classification error. But 70% of error for validation in just 10 epochs. Also, you can appreciate that a trend of validation has inverted. Like now validation is under the training curve, sort of telling us that we are suffering from underfitting, like doing like consciously using the dropout. We have already reached 30% of error, okay, in 15 epochs, while before it took us like 40. We're even going like down 30. It's quite amazing what and it's also nice to observe that now objective laws for training and validation are quite close. Okay, I'm gonna stop the video. See you back after a couple of epochs. Okay, and this is what we achieve at epoch 60. So I think it's a quite a nice improvement. So we moved to almost 25% of error. So we jumped from 30 to 25 thanks to dropout. So it's just 5 points. Sometimes 5 points are quite a lot, especially if we consider that we are using just like a reduced data set for training. So I hope this helps a little bit to make you understand the importance of dropout when trying to improve generalization of these methods. And if you keep following the script for this session, you see that now you have the chance to play a little bit with dropout, like trying to put them in different places, changing the rate, like what happens if you have just one, or what happens if you have more than two in different places, playing with different rates, what happens if you are more aggressive with the dropout and instead of having 0.5 or 0.7 you have 0.9. So I would like you to play with this thing for a while, so and check the results and try to justify why things are they are. Okay. Have fun.